All right, everybody. Thank you for coming here today. I'd like to start with just a quick story, okay? This story, does everyone know what the Thunder Run is?
Oh,
yeah,
yes.
yeah, okay. So the Thunder Run, right, April of 2003, 3rd Infantry Division, okay, 164 Armor. They were making the charge into Baghdad, okay? If you're unaware, Baghdad is surrounded by the Tigris River, okay? The Tigris River has multiple crossing points all over it, okay? As a scout, right, one of my section leaders when I was a brand new private was part of the Thunder Run in 2003. And he was in 164, and he actually used this method real world in combat, okay? What he did is they came across a bridge that had been blown out by the Iraqi army earlier. And it was like the only place that they could actually cross the Tigris River to get into Baghdad, okay? So them being able to cross at this particular point was very important tactically and to the mission, okay? So in 2003, we didn't all carry around little supercomputers in our pockets, okay? There wasn't the abundance of gadgets and gizmos like there is now, okay? So what he did, he pulled out his compass and he took measurements and he used the technique that I'm going to show you guys, and he determined the proper width across this river, and the engineer assets were able to come up and bridge that river and allow the armor to cross over into Baghdad and capture Baghdad. All right. Now I'm going to read my thesis straight from the paper. Right. The thesis is: knowing how to use this method of determining distance is important to know because you cannot always depend on technology or gadgets in order to accomplish your mission. Okay. Now, first, I'm going to talk a little bit about the importance of understanding how and why this process works. Okay. Then I'm going to discuss a little bit of the math that actually makes it possible, and then I'm going to demonstrate on how to actually do it. Okay. So first, I would like to say I've been a scout for 18 years. I've used this several times in Korea, NTC, all over, in different training environments. I know for a fact that it works and that it's proven. All right. So we're going to start with the soldiers in my story. Right. They use this method because, like I said, nowadays we all have these little rangefinders, right? That wasn't a thing in 2003, at least not in the same way that it is now. Okay. The soldiers that were conducting this mission were real time, real speed, some of the most violent combat that we've, as a country, have seen since Vietnam. They had to have a surefire way to make this happen and make sure that it's as accurate as they possibly can be. Okay. Now I will say, of course, this isn't going to be like Albert Einstein scientific level accuracy, right? I wouldn't put this up on a machine shop and call it good. But it is extremely accurate for what it is, and it works every time. All right. Now, going into how it works. This method is possible because of isosceles triangles, right? Basic geometry, okay? If you take a triangle and you have one right angle already, and you create two 45-degree angles, the distance will be the same from A to B and A to C, all right? If you have one 90-degree angle and two 45-degree angles, it will be the same. That's just the way math works, that's the way geometry works, okay? Now, going into how it actually happens, all right? So the first thing we need to know is the number 0.75, okay? That's meters, by the way. So 0.75 is the average pace of an American soldier, okay? So that's not the shortest dude, it's not the tallest dude, it's the average, okay? The average person takes 0.75 of a meter step, okay? That's important. Then, the next thing you need to know is how your basic one-sided compass works, which we all know how this works, right? Okay. So, what you're going to do, right, let's say you have your river right here, okay? and you're trying to find a way to cross it. You need to know how far across it is, all right? First thing you need to do is find you a spot to where you can see across the river, okay? So we're gonna say that that's right here for us, point A, okay? Then you need to find something that is as close to the bank as you can, like a rock, a tree, something, right? We're gonna call that point B, all right? So then what you do is you take your compass, right? And you shoot an azimuth with your compass, okay? From point A to point B, all right? For sake of easy math, we're gonna say that that's an even 360 degrees, right? True north, okay? Then, now we're gonna get into the second thing you need to know beforehand, right? I'm a big Metallica guy, right? So I always think of Lars Ulrich, right? The drummer for Metallica. Left add, right subtract, okay? So that means that if I choose to go right, I'm gonna subtract 45 degrees, right, off of my 360 degree azimuth. If I go left, I add, okay? So that would be 45 degrees, okay? So in this case, we're gonna go right, just because that's where I have space, okay? So we're at 360 degrees, okay? You're gonna make sure that you mark your starting point. You're gonna take a few steps, check again, shooting back to point B, right? Take a few more steps, shooting back to point B, until you hit, in this case, it'll be 315 degrees, okay? Right? See, remember what I was talking about with the creating 45-degree angles, right? Now we have a 90-degree angle here, and because we measured out 45 degrees from our start point, we now have a 45-degree angle here and a 45-degree angle here. Okay, so we have created our isosceles triangle. All right. And then obviously it's the same way if you were to go left, it's just instead of 315, it'd be 45, okay? Anyways, so you're over here at your point C, okay? And now you just walk back to the start point. 1, counting your paces. 2, right? Boom, 5. So you take 0.75 times 5, which what is that? Someone do the math. It'd be 1.25, right? Yeah, 1.25. 1.25 meters. So that means that this little area that I measured is 1.25 meters, right? We all know the meter is roughly 3 feet, right? Right, that's about right, right? And then, yeah, okay. 1.25 meters is the overall length from here to here, okay? Now, that's gonna work the exact same if it's 50 meters. Someone please do the math for me. So 0.75 times 50 paces is how many meters?
0.75 times 50 is 37.5.
37.5 meters. So that means that you have to have a bridging asset that's 35 or 37.5 meters long to cross this gap if your pace count is 50. Right? And that's it. That's how it goes. It takes just a few minutes and you're done. All right? So in conclusion, I'd like to reiterate that how knowing this is extremely important because we can't depend on gadgets and gizmos all the time, right? A lot of time in the Army, right, we do land nav, okay? We have to use a map and a compass in order to find our way around, okay? People ask why not just use GPS? Well, because what happens when that goes out, right? You still have to know how to find your way around, okay?
Absolutely.
So overall, I hope that you guys have learned something from this, okay? And I hope that you guys understand how important something as simple as one soldier and his compass can be to the greatest military action in our lifetime, in our generation, right? Obviously, you have any questions, I'll just hang out and you can ask them. Other than that, I appreciate you guys for being here and have a good day.